Hi everyone, this is Darren here, and today I'm going to cover the topic of algebraic fractions. So basically, this is just a slightly more in-depth video because I have covered simplification earlier in another previous video. So this also will be on simplification, but specifically right now we're going to combine algebra with fractions. So I personally feel that I've seen my students make slightly more errors when this topic arises, so hence this video. So please follow along, and I'm going to cover 6 examples. So I hope that you learn something and enjoy. Alright, here's my first example. Suppose we have 2a over b multiplied by 3b over 8. Alright, so what I really want to teach here is that when there's algebra and fractions combined, generally you're able to cancel out terms. And when I say cancel out, I'll elaborate further. But what happens is that we know that 2a times 3b gives us 6ab, and b times 8 gives us 8b, correct? So we do that, and then we see there's a b here and b here, then therefore we cancel out. So it's very clear cut, right? And then from here we simplify and get the answer. But we can actually cancel out earlier, and that will save us time. So you see that actually, if I do it slowly and I cancel out here, it's fine. But rather, if I actually notice that there's a b in the denominator and a b in the numerator, I can cancel them out. So that's the logic. You can cancel out, if there was a b here, you can cancel out these two. Okay? And if there's a b here, you can cancel out these two also. The thing is, if there was a b here and here, you're not able to cancel out. Okay? So when you're cancelling out, take note that you must always cancel out a numerator, a term in the numerator with a term in the denominator. It doesn't matter which denominator. So like, if there's a b here, right, and if there's a b here or here, either one you can cancel out, it's fine. But you can't cancel out the denominator with denominator and numerator with numerator. Alright? So okay, if you didn't understand what I was saying, you can observe the other examples, and I'm sure you'll get a better understanding and a clearer picture. Okay, so now this leaves us with just 6a over 8. And this, we can simplify one step further, divide by 2 on both sides, and this just gives us 3a over 4. And yes, this would be the final answer. Okay, great. Let me move on to the second example now. Okay, so say we have this as our second example, 3h over 5k multiplied by k square over 6h. Okay, again, we have to remember our first example, recall from there, and we know that k here and k here, we can cancel. So I'm going to remove this k, and I'll remove the square here, because k square is just simply k times k. So I want to remove 1k, because I must be fair. I'm removing 1k from here, I must remove 1k from the numerator. So 1k in this case is being represented by the 2. And here we have a h and a h. So therefore, I'm going to cancel also. And now, one more step we can actually do is realize that 3 and 6, they have a common factor, and that is 3. So I can actually simplify this even easier, even further. This will just be 1, and this will just be 2. So we have a new numerator, a new denominator. So okay, 1 times k is just k, 5 times 2 is just 10. So this would be our final answer. You see how by cancelling here we actually save time, rather than just multiplying, and then cancelling only here? Yes, so I'm going to advocate this cancellation method to help you save time. Okay, let's move on to the third example, where it gets slightly more tricky. I'm going to introduce more unknowns into the equation. So suppose we have 15a, sorry, I think I write too small, let me rewrite. So 15a y cubed over 50y multiplied by 5y y square over ab. Okay. Okay. So this is the question, and see there's three variables a, y, and b. So let's see. There's a y here, and there's a y in both sides. So we can actually just go ahead and cancel them out. So cancel this y, and y square we cancel out, right? So this will just be y. Okay, and now a here and here we can also cancel out, and then this b here, there's no b on top, so actually we have to just leave it, so this is fine. And then now we look at this 50, you see, aren't they all just multiples of 5? So I can again cancel them out. So I cancel out this 50 and I cancel out this 15, divide both sides by 5, this gives me 3, and this gives me 10. And then this 10 and 5 we compare, again both sides can be divided by 5. So I divide this by 5 will give me 2, and this will just give me 1. But if it's 1, I won't write a 1 there because it's a y. 1 times y is just still y. So I'll leave it as such, and then this will be just 3y cubed times y over 2b. So this will give me 3y to the power of 4 over 2b. So you can see how cancellation really helped us. From something so many terms, we just, with a few cancellations here and there, we're able to get and simplify the answer quickly. Alright, so move on to the fourth example now. (81) CD cubed over 27 C square multiplied by 4 CE cubed over 6 DE. Alright. So again, three variables as you can see. So I see C square here, I see C here and C here. This is great, you know why? There's two C's on top and two C's below, in a way, because it's C times C, right? So it's C times C also. So I'm just going to go ahead and cancel out this C square, cancel out this C here, cancel out this C there. So what I've done is fair, and that's very important in maths. It must always be fair. If I cancel out C square from the top, cancel out C square from the bottom. So now there's a D here, I cancel out this D, I cancel out D from the top, which will give me D square instead. And now the E, again do the same thing. So remove this E and make this an E square instead. Because when you have an E cubed, that's E times E times E, right? You divide it by E, you'll just get E times E. So this is why I'm writing E square. Okay, so now let's just leave us with the numbers here. And I see that 81 and 27 can be divided together, because both of them, this is just 3 times of 27. So I cancel this and make it 1, and I cancel this and make it 3. So this just leaves us with, I can go further actually, okay, yeah, but let's say I think I've done enough cancellation, right? I don't want to make it too messy, so I'm just going to write down the details here and then solve one more step later on. It's fine also, it's how you want to do it. That's the whole beauty of this cancellation method. You don't have to cancel all, you don't have to cancel just some, you can cancel your choice. Okay, so 3d squared times 4 giving me times 4e squared gives me 12 d squared e squared, and 1 times 6 over 6. So now see, 12 over 6, I can do one more step. This just gives me 2d squared e squared. So it's not always you have to cancel all, like I don't always have to cancel here 2 and put a 3, you know. Sometimes if it's not so clear to you, it's fine to just take another step and to get the answer. It's fine. Don't always have to cancel all at the start. Alright, so let's move on to the fifth example now, where it gets even more complicated. So this fifth example, we have 3m to the power of 4 n over 12m n minus 2 multiplied by n n minus 2 square over m square. Alright. Okay, so this example here, what can we first see? We see a m to the power of 4, n and n minus 2. Right? So they are, in a way, two variables. But this n minus 2 is a bit different from this n, so we have to take note of that. Okay? But thankfully, we have an n minus 2 in the denominator and n minus 2 in the numerator. Hence, we can just still cancel out, because n minus 2 square is just n minus 2 times n minus 2. So if I cancel n minus 2 from the denominator, I can cancel n minus 2 from the numerator. So just give me as such. Okay? So now, m and m square. So in a way, we have m cubed in the denominator, and we have m to the power 4 in the numerator. So I'm going to cancel out all the m's from the denominator, and this will just give me m, right? Because m to the power 4 divided by m to the power 3 gives me m. And now, here 3 and 12, simple, divide by 3. This gives me 4. So now, and then of course there's a 1 here. So the denominator will be 4. And the numerator will be m n square n minus 2. Okay? So this is how we do this question. Slightly more complicated, but still can be done. Cancellation still applies. Alright? Okay, so let me move on to the last example. Hope you're still following along well. So, alright, last example coming up. So we have 2x minus 1 square over 3b multiplied by 6b cubed b and 2x minus 1. So now what do we do? Alright, so here again we have a 2x minus 1 in the denominator and in the numerator. So straight away we can cancel them out. Okay? It's very important that they are exactly the same. Okay, if this was 2x minus maybe 4, we are not able to cancel out. Okay, and then it will be really difficult to simplify. Okay, but just take note on this that they have to be exactly the same. So they have both have to be 1 and 1. Okay, 2x minus 1, 2x minus 1. And now 3b and b here, this gives me 3b square, right? 3b square divided by, 6b cubed divided by 3b square will just give me a b, and here give me 2. Cancelling everything out. I did it slightly faster, but you can understand why, right? Because if I just extracted that previous step, it would have been 6b cubed over 3b square. And this just gives me 2b. Okay, so that's what I was doing, I was cancelling it out. So that's why we are left with 2b over here. So finally, our denominator will have 1 in both sides. So we won't have to write denominator, because we'll be writing like answer over 1, right? If you have this, you know that you do not have to write over 1, because it'll be pointless. So that's why I won't write the answer as over 1. So I'll just, when I see 1 and 1, I won't write any denominator. So therefore the answer will just be 2x minus 1 times 2b. And then if you want to expand it, it's okay also if you want to. Or you can express the answer as this is fine, or this is also fine. So either one is fine. So with that, I hope that you enjoyed and learned something from this video. And as always, please like and subscribe. Thank you very much.